So for number 7, they want you to find the value of a and b, and so that the equation is true. Okay, so that the left side equals the right side. So if you look, a is the real part and 9 is the real part. So then we know that a equals -9, and then b is a coefficient of the imaginary part of the number, and 4 is a coefficient of the imaginary part on the other side. So then b equals 4. For number 9, 3a has to equal 9. So 3a equals 9, so that means that, that a equals 3. And then b plus 3 has to equal 8, because that's the imaginary part of coefficient of each number. So then you set b plus 3 equal to 8, and so b equals 5. For number 11, you have to simplify and write the number in standard form. So remember, square root of -9 is square root of -1 times square root of 9. So that gives you 4 plus 3i, because square root of -1 is I and square root of 9 is 3. Okay, so we're subtracting. So we need common denominators. So a common denominator would be, I'll just put one right here, 1 plus I times 1 minus I. So then the first fraction, this one, the first term, needs this in its denominator. So I'm going to multiply top and bottom by 1 minus I. So that means that the 2 gets multiplied by 1 minus I. So you end up with 2 times 1 minus I minus 3. And now this one needs 1 plus I, right, to get to match up with this denominator. So we're going to multiply top and bottom by 1 plus I right here. And so that means that 3 gets multiplied by 1 plus I. Okay, so now we distribute, and so we get 2 minus 2i minus 3i over, multiply the bottom, the denominator, so you get 1 minus I squared, because the I and the negative I cancel out. So now I have -1 and then -5i over I squared is -1 in the denominator, so there's a negative in front of it already, in front of the term right here. So this is going to become 1 plus 1, so that's 2. So to write it in standard form, you just separate the real from the imaginary, so it's -1/2 minus 5/2 I. So that would be the final answer. Okay, so for 62, you have to perform the operation, write the answer in standard form. So square root of 50 is square root of -1 times square root of 50. And we know that we can simplify the 50 as 25, or factor it as 25 times 2. Over here on the other term, it's the square root of -1 times the square root of 275, and 275 is 25 times 11. Okay, so the 25 comes out, and square root of -1 is I. So 25 comes out as 5. So for the first term, I get 5i square root of 2. For the second term, I get 5i square root 11. They're both i's, so we combine it by just factoring out the I and putting 5 square root of 2 plus 5 square root 11, like this, I. So this is the coefficient of I. So 65, remember, first we change the number to standard form before we multiply. So this becomes I square root of 6 times I square root of 2. Now we can multiply, so we get I squared square root of 12, and 12 is 4 times 3. So the 4 comes out as a 2, and the I squared is -1. So -2 square root of 3 would be the final answer. Okay, so for 68, whenever you square a square root, you're just left with the radicand, so this would be negative 75. For 71, we're now solving the quadratic equation. So x squared plus 25 is 0. When there is no b term, I just isolate the x, because b in this case is 0. So I have x squared equals negative 25. I take the square root of both sides. So then x equals plus or minus the square root of negative 25. Now 25 we know is 5 times 5, right? So the square root of 25 is 5. And the square root of negative 1 is I. So this answer is plus or minus 5i. So 74, we're going to use a quadratic formula because it doesn't factor. So x equals negative 6 plus or minus the square root of b squared minus 4 times a times c, that's a 10 in there, all over 2a. So then you get negative 6 plus or minus 36 minus 40, all over 2. So that's negative 6 plus or minus square root of negative 4 over 2. So you get negative 6 plus or minus 2i, because square root of negative 1 is I, and square root of 4 is 2 over 2. And then I'm going to factor out a 2 from the numerator so that I can I can get rid of the denominator. So I can reduce it by 2 over 2, which is 1. And so the answer is negative 3 plus or minus I. Okay, so now t equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So now you get 4 plus or minus 16 minus, let's see, 12 times 16 is 192, all over 12. Sorry, all over 32, not 12. I saw the 6, but it's 16. So 32. So you get 4 plus or minus square root of negative 176 over 32. 176 is 16 times 11. So this is 4 plus or minus, we write it right here, 16 times 11. So the 16 comes out as a 4. The negative 1 comes out as an I. So it's 4 plus or minus 4i radical 11 all over 32. So now I'm going to factor out a 4. Over 32. So the 4 goes into 32 8 times. So the final answer is 1 plus or minus I radical 11 over 8. And that's the value of t. Alright, so the number 80 has fractions. So I'm going to find the least common denominator and go ahead and multiply by each term on both sides of the equation. So that would be 16. So I'm going to multiply each term, like I said, by 16. I'm going to squeeze it in here, 16, 16, 16. Okay, so when you simplify that, you get 8 into 16 is 2 times. So 2 times 7 is 14x squared. 4 goes into 16 4 times. 4 times 3 is 12. And then 16 goes into 16 once, so 1 times 5 is 5. And 0 times 16 is 0. Okay, so now we're going to set up the quadratic formula. So it's set up negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so minus the negative 12 is positive 12. The negative 12 squared is 144. Then 4 times 14 times 5 is 20 times 14, so that's 280. And then 28 in the denominator. So now I've got 12 plus or minus square root of negative 136 all over 28. So 136 is 4 times 34. So the 4 comes out, and the negative comes out as an I, right? So now I've got 12 plus or minus 2I, square root of 34, all over 28. So I'm going to factor out a 2. And 28 is 2 times 14. So the 2's reduce, they're gone. And so your final answer is x plus or minus square root of 34 over 14. Remember, you cannot reduce the 6 and the 14 by 2 because you would need a common factor right here, and you don't have one. Okay, so for number 90, it says that without graphing, for part A, determine whether each function has x-intercepts. Well, I know that the vertex on f of x is 3, negative 4, and I know it opens up. Okay, so 3, negative 4 is below the x-axis, and it opens up, so this one has 2 x-intercepts. For g of x, the vertex is the same, 3, negative 4, and it opens down, because a is negative. And so 3, negative 4 is below the x-axis, and it opens down, so this has no x-intercepts. Okay, for part B, they want you to solve each one. So they want you to find f of x is 0 and g of x is 0. So that means we replace the f of x with 0 and then solve. So remember we can distribute and all that, but when it's set up like that in vertex form, it's easier to solve like this. So I'm going to put 4 equals 2 times the quantity of x minus 3 squared. I'm going to divide by 2. So then I get 2 equals x minus 3 squared. I'm going to take the square root of both sides. So then I get plus or minus radical 2 equals x minus 3. So the final step is I'm going to add 3. And remember, you could only add like terms. So then this tells me that x is 3 plus or minus radical 2. So those are my 2 x-intercepts. Over here on the other side for g of x, 0 equals negative 2 x minus 3 squared minus 4. I'm going to add the 4 just like I did on the other, on f of x. So 4 equals negative 2. And so I'm going to divide by negative 2. And so negative 2 equals x minus 3 squared. I'm going to take the square root. And so right off the bat right here, I know that it's going to be an imaginary number for x, not a real number, because I have a negative inside the square root. So it would be plus or minus I radical 2 equals x minus 3. I'm going to add 3. And so x is 3 plus or minus I square root of 2. So that would be the value of x in g of x. So for part C, they want